calculation notes. You now have the file right here, and you have the centimeter ruler. We're going to do some calculations, so you'll maybe want to come back here to have that address. You can also do a Google search, but it's right there. We're going to be using trigonometry today, and your calculator on your iPad or phone can handle that. If your calculator is in portrait mode, it doesn't show trigonometry, and then if you go horizontal, then it gives you all of the sine and cosine and tangent and things like that. So we'll be talking about that in today's class. I'll also be passing out some rulers, but it's kind of cool how you can even use this centimeter ruler and lay it right over on top of your document. So when we get to the ruler part. So you can see that we're defining a few of these terms right here, and blood pattern analysis. It is abbreviated as BPA, blood pattern analysis. So blood is usually very prominent in crime scenes, and there's a lot of patterns to it. We'll be going over those patterns. And there are some ways that you read the blood and do some calculations on it, and you have to be pretty accurate with it. So what is blood pattern analysis? I have my textbook, and I've highlighted. So you can go ahead and highlight as well, and you can see that the answers are going to be put into the question. So what is blood pattern analysis? It is the examination of all of the blood stains left at a crime scene, and then they're interpreted to the point where it can recreate a crime scene. There's the laws of physics involved. There's the laws of mathematics. So we're going to be able to get a lot of details with blood spatter. It's one of the great techniques at a crime scene. So question number 2, or Roman numeral 1 and then letter B. What is one of the most important jobs of a BPA, blood pattern analysis analyst? That's my second highlight right here. One of the most important jobs is for them to determine the sequence and types of events that occurred that made these wounds. We saw a CSI episode in the first semester where it was a chainsaw. Did we see that one? Where some guys were fighting and they thought that they were killing each other with chainsaws, and they had all these marks in the ceiling where the blade threw blood and everything. Did we see that scene? Yes, no?
I don't think so.
Okay. So I'll try to show that to you in a subsequent class. So it's pretty interesting how the analyst will be there, and then they start going, all right, now I think this happened. They came in that door and they did this and they swung it this way. And so depending on the type of weapon and the speed at which someone is bleeding, it's called low impact, medium impact, and high impact blood spatter. And when you hear me say that, I'm pretty conscious of not saying an L inside of that. So when you make your movies, right from the get-go, don't say splatter. It shows that you are inaccurate and you want to sound professional by using the correct word. It's easy to slip into splatter because we use that word more than spat, but it's blood spatter. So that is the job of the analyst. They are like the detectives that are analyzing individual blood, and it could take days or a week or more to analyze a lot of blood. They're going to analyze and calculate thousands of blood angles. And then they're going to do things with that known angle, work backwards to see that point of origin. And it might be in a three-dimensional space. They can use lasers, they can use strings. And so this is a pretty detailed part of forensics. Question C, what are the many disciplines? As I mentioned, there's physics, there's math, there's geometry, biology, chemistry. Just about all the major sciences are involved in blood pattern analysis. So again, I highlighted that. And if you're in the textbook, it's also okay for you to do a copy and paste if you want to do that, or if you want to write it out. So now the basics of blood stains. I already mentioned that it's blood spatter, so there's how the spelling of it. And that's defined as scattering of blood stains, and they're going to vary in size. They're produced by various methods. In my earlier description, I even used the word origin. So that's what they're trying to get at. They're trying to work backwards. Once they have the angle of the impact, they will then draw it in a three-dimensional space, either with a computer program, strings and lasers, and they will point to a common area where they came from. It's called the area of convergence in two-dimensional space, and then when they go on the y-axis for three-dimensional space, it becomes the point of origin, or the area of origin. That's defined as the region or the area where the blood originated, and when blood hits a surface, those are called the target surface areas. And now we have a blood stain on our screen, and we're on letter C, where it talks about the parts of a blood stain. They're labeled in that picture, and it would be a good idea for you to quickly sketch that over on the side, and then you could point to the areas. The parent drop is the main blood stain. It's not necessarily going to form a perfect shape depending on the type of surface that it hits. So you're going to have irregular edges often, and you're going to have, because of the speed and the volume of the blood, you could have satellites, but it came from the parent drop. And then you can also see along the edges of the blood stain, there's going to be spines that reach out, almost like the spines on a porcupine. And rarely are they all the way around. They're going to be moving in the direction, the spines are going to be in the direction of the movement. So if down toward the right is the only place where the spines are, then that was the direction that someone was moving when the blood hit the surface. So the spines always point in the direction that the blood was traveling. So if you want to know where it's coming from, then you would work backwards that way. Up to the left is where it originated, and it's moving down to the right. But you can also see some spines a little bit right there. So this hit an irregular surface, and it could have been a piece of carpet that it hit first, and then it caused the spine to go that way. So looking at one blood drop is difficult to determine really what's going on, but when you start adding hundreds and thousands of these, then it really makes a difference. So you got the definitions right there for parent drop, a satellite, and a spine. We'll see quite a few examples on the following pages here in the notes. So just a few more things to talk about before we get into the action of analyzing bloodstains on the following pages. So the next part of the notes are what do the surface tension, cohesion, height, angle of impact, how do all of those affect the blood drop? In biology class, we talk a lot about water, and water has amazing properties, and blood is about 50% plasma, which is a watery solution, and so it's got the properties of water, which is cohesion. Water sticks to itself because of van der Waals forces. Remember that from chemistry class? A molecule that has a slightly positive side and a negative side, it's magnetically attracted to the opposite. So one side of water is slightly positive by the hydrogens. Oxygen is slightly negative, and so they stick to opposite water molecules on the opposite sides. That's cohesion. Cohesion is the attractive force of a polar molecule. So blood tends to stick together. And so it's going to fall through the air as a perfect sphere. And then it will hit the surface. And by the way, surface tension is related to cohesion, so that's why it sticks together and has a surface tension. That's why you read the bottom of the meniscus, because the water's sticking to the sides of the glass. So blood has that kind of similar effect where it's going to be attracted to different surfaces. I think it's the next class where we're going to have a blood lab where you are going to be creating blood at different angles, and you are going to be instructed to do it from a meter away. Sometimes students are going to put it really close because they want to be accurate and not miss the paper. So if you do that, the blood drop is really small. If you do it from a higher distance, then it has more gravitational acceleration, and it's going to hit at a bigger speed and then cause a bigger blood drop. So this is just kind of giving you an indication. So the diameter is going to increase the higher up that you go from the bleeding incident. And that's a pretty good picture showing the spines all the way around. If you have spines all the way around, it hit at a 90-degree angle. And if the parent blood drop, it is pretty uniform and circular, then you know that's a 90-degree. And we'll calculate and we can show that that's the case. So this is kind of a good picture too, where the spines, if they're going in one direction to the right, then that was the direction of the blood and it originated to the left. So the angle of impact is shown in the textbook. This is similar to what you're going to do in the lab. If it's at 90 degrees, it's nice and circular. And as it strikes at more of an angle, it is going to make the length of the blood drop really stretch out. So that's hitting at a 10-degree angle, which is almost what you see in this picture right here. You have a lot of examples down below, so you don't have to. We're going to be sketching what coming up in the next questions, E and F. Draw a picture of how blood stain pattern analysis works with the right angle triangle. So you're going to be drawing it there. So the angle of impact is determined by trigonometry. I haven't highlighted that yet, so I will. And it's by the sine, S-I-N-E. It's abbreviated S-I-N, like sin. So you'll see it both ways. It's usually in its three-letter abbreviation instead of spelling out the whole word. So the major trigonometry functions are sine, cosine, and tangent. Does that sound familiar? Have you had math classes with right angles? I wasn't very good at it in high school either. And when I started teaching it from this perspective, it makes a lot of sense. So we're going to spend some time explaining how these three trigonometry functions relate to a right triangle. So now we're on this question. D, letter E. Draw a picture of how the blood pattern analysis works with the right triangle. So now sketch this out for that question. We're on letter D, subletter E. Draw the picture. So what you see right here, draw a surface, and then here's your right triangle. See that box right there? That signifies that that's a 90-degree angle, and so that makes this a right triangle. So when you have one 90-degree angle right there, so as the blood drop is coming in, this is the width of the blood, so that's going to become this side of the angle. So go ahead and sketch that out. The key angle that you are calculating is right down over here. You see that arrow that goes from the top line down to the surface? That has a little symbol there for, hey, we need to calculate that angle. It's a variable. So we're going to calculate that angle of impact. So in your right triangle now, label that the width of the blood is this red angle of the right triangle, and the ground is the length. I'll highlight this for you. In your sketch, you should write that this is the opposite side. So you see how it's labeled the opposite? So here's the angle that we're going to try to determine. And this is opposite the angle. So that's what that means in a right triangle. The long part of a right triangle, the long length of the line between A and B, that's the longest one. That's longer than A and C and B and C. So this is called the hypotenuse. That's what it says right there. That's like hypotenuse. So instead of like writing out opposite, you call that the O side. So this is the O, and this is the H. This side that I haven't talked about yet on the right triangle, this side is called what? Anybody know? We're getting at SOHCAHTOA. Have you heard of that before? So the sine is the opposite over the hypotenuse. The opposite over the hypotenuse. So those are acronyms that help you remember what trigonometry is. And so we're just focusing in on the sine right now. So this other side right here is the A, and it stands for the adjacent. And we're going to deal with that later when we're dealing with the angle of impact for bullets. And we're calculating the height off the ground. Then we get into the tangent function. Then the last question over here, what is the formula for calculating it? It's right here. The angle of impact equals, and you're going to write, it says arcsin. The arcsin is the width divided by the length. Or in other words, it's the opposite over the hypotenuse. So the width is the opposite, and the length is the hypotenuse. Did I say that right? The width is the opposite, and the length is the hypotenuse. So, anybody know what arcsin stands for in trigonometry? It means the inverse sine. Have you heard of that? Yeah, this might be new to you, and it's only getting complicated because all the things that I'm writing on the screen. So I'm going to erase that. So this is often written like this: sine minus 1 equals width divided by length. So that means the same thing when you see it as a minus 1. That means that it's now in the denominator of a number instead of the numerator. So it becomes, and you signify that with a minus 1. This is pretty easy to do on your calculator. You just have to hit the inverse button and then sine. So we're going to do some of those calculations. If you get an error on your calculator, the first thing you have to look at is this bottom number has to be the larger number, right? Because that's the longer length. So sometimes students will make the mistake and go length divided by width, and then when you're trying to calculate it, it then gives you an error and you're wondering, hey, what's wrong? You're always dividing by the larger number. So even though this information is written down for you already in the following pages, it's good for you to write it down yourself so you can practice it. You can practice writing a right triangle and saying what these angles are. So here it is again. So check your drawing against this. So there's the right triangle. If we're calculating this angle, letter C, we're going to go opposite over hypotenuse. So you're going to measure the blood. You're going to measure the width of the blood drop. And then you're going to measure the length of the blood drop, 2 measurements. And then you just do one quick division, width divided by length, you have that number, and then you go to trigonometry. If you're using your calculator already, do you realize that there is something called degrees and radians? So in trigonometry, there are 2 ways of getting an answer, and you have to make sure that your calculator is going to give you the answer in degrees. So it's not going to work if you are, it's a toggle button. You have to make sure that you want the right answer. That's almost like saying, do you want grams or do you want ounces? So you have to be in the right unit of measurement. So here's an example. You just take your ruler and you measure the width and then you measure the length. It doesn't matter if I measure it at this aspect ratio, as long as the width and the length stay in the same relation to each other. I could also measure it this way. Then both numbers are going to be larger, but as long as I don't mess around with the width when I'm doing or the overall magnification, I just need to measure that one and that one using the same magnification, and you'll get the same answer. So you can measure it this tiny, or you could measure it larger. You'll be a little more accurate if you make your pictures larger. So when we do this in the lab, you're going to be bleeding on the paper with this fake blood, and then you're going to take a picture of it, and then you can expand it. That way we can work with it, and we don't have to wait for the paper to dry and stuff. So what we're doing in class right here, calculating, is similar to what you'll do in a follow lab. So it's 7 divided by 15. And they didn't do the calculation, but you do that first. And then you hit the sign -1 button, and it gives you that angle right there on the screen. Let me see if I can find a calculator. If my calculator shows that. All right, so it's going into a game, so I have the financial calculation. I think I thought I had another calculator on here. All right, good. So I'm looking for the shift key. So you see the sign and the sign -1. This is the shift key, and I think it's right there. So what was it? 7 divided by 15? And it says degrees right up there, so that's good. I think if I were to hit that little, first time I've used this calculator in a little bit, sorry. So let's just try that. 7 divided by 15. Got the answer. And then you hit the shift, and now sign -1 is down here, and then I hit that. 27.8 degrees. You're not going to have to worry about carrying the decimal place, because this is only accurate to 5 degrees. So it's really 28 degrees plus or minus 5 degrees. So that could then be shown as 23 degrees or 33 degrees. So it could be in that variation. All right, so that's not too hard. Let's go back here and do some examples. Go ahead and grab that ruler. So have you done that yet? Did you? Over at the Canvas assignment, I had a JPEG of a ruler. And this one is already part of the PDF file, but I brought this one in from a picture. So now you can go over here do the angle calculation and show your work. So I could make the ruler larger or smaller, it doesn't matter. And I'm going to put it over it. And notice with this, if I put my finger on the ruler, it becomes transparent, and that's kind of helpful because then I can see where it goes. You don't want to measure the spines. So if I press and hold this, I have 20, I'm going to call it 21 millimeters. So between each of these numbers, 1 and 2, these are centimeters, there's 10 millimeters in each centimeter. So I could read this as 2.1 centimeters, or I could say 22 millimeters. So I'm going to call it 22 millimeters. And if you can see, I'm not including the spine. So I'm just doing the parent drop. So I'm going to say that the width is 22 millimeters. Your number might be different depending on how wide you made your ruler. And now with this ruler, I can tip it up. And then this is, I think I called the other one 21, didn't I? 21, 22. I think I remember it being 21 instead of, but the length I have is 22. And then the length, 22 millimeters. (21) divided by 22 equals, I'm already in the sine minus 1, so I don't have to hit the shift key. In this case, it's already shifted. So sine minus 1, that's a 73-degree angle. Even though it looks pretty circular, I guess it does look a little bit longer right here. So that could be 78, 80 degrees, very close. Angle calculation. We're going to do one of these two. Hard to read that one. So sometimes you're going to have blood drops that if it's just one all by itself, it could have been coming in from a different direction with a hand moving in one direction or something. So it's hard to read that one. But this one definitely has a length to it. It's hard to see the direction. This looks like a gravity drop. It looks like it hit a surface and then some of it just trailed down. So let's talk about where you draw the line. I don't see any spines, so really you can take it from basically right there. This one, however, if I zoom in on it, I'll change colors. So if this was, that's a pretty big tip. I would stop it right about there where I have the blue. All of this is a drip trail. You don't include that. You don't include spines or drip trails. And so you see how it's got that form to it? You would shape it as soon as it stops getting narrower and then just stays the same, that's where you stop measuring it. So go ahead and do this one and do that one, and then we'll do this one right there. You see that there's two blood drops that overlap, and the drip trail stops right about there. It is hard to get the left-hand side. So there's a little bit of an interpretation there. Use the ruler, get the width of each one, get the length of each one. Then you have your answer, and you're going to do sine -1 on each one. Let me come around and see how you're doing. Would anyone like an actual ruler that you can lay over the screen?
Well, my calculator
Are you on degrees or radians? There's, yeah. And there might be a button or some percentages. So that's the problem. On some calculators, I don't know.